In today's lesson, we want to learn how to solve systems of equations using graphs and tables. To begin with, let's talk about some definitions. A system of equations is a set of two or more equations written with the same variables. A linear system is a system of equations that consists of linear equations, equations whose highest exponent will be a 1. A solution of a system is a set of values, usually in ordered pair, for the variables that makes all the equations true. What we want to do first is we want to solve, one way to solve a system of equations is by graphing. To solve a system of equations by graphing, you graph each equation on the same coordinate plane, and your solution is the point of intersection of the lines. Always write your solutions as an ordered pair, x comma y. Let's take a look. What is the solution of the system in example 1? X minus 2y equals 4, and 3x plus y equals 5. To do this, let's use the Desmos graphing calculator. So, with Desmos, we don't even have to, we can put them in standard form. X minus 2y equals 4. And our second equation, 3x plus y equals 5. It's up to a 5. So we get rid of this. So as you can see, as I'll zoom this out, where do the two lines cross at? We can see that they cross at 2, negative 1. Thus, our system of equations answer. Graph each equation, put them in Desmos in standard form as I just showed you. Where do the lines intersect? Well, they intersected at 2, negative 1. Thus, the solution to the system is 2, negative 1. Another way to find a solution is by using tables. A great way to do this is through Google Sheets. Open your drive and open Google Sheets. 2x minus y equals negative 1 will be one of our equations. And our second equation will be 1/2 x minus 2 equals y. We're going to make column A the x values. We'll put our first equation 1, into column B. We'll have to put it in slope-intercept form. We'll put equation 2 into column C. Let me show you how this is going to work. So as you can see, I open up my Google Sheets. In my first column, I'm going to put this as my x values. My second column, I'm going to put my first equation. Remember, it was 2x minus y equals negative 1, so I'm going to rearrange it and get y equals 2x plus 1. My third equation, or second equation, excuse me, y equals 1/2 x minus 2. So in my first column, I'm going to make this my x's. So I'm just going to start with some random value. Let's say start with negative 8. Now, the nice thing about Google Sheets is I can tell it to do a formula. So in column A3, so notice I call this A3 because I'm in column A, row 3, so I'm going to go equals. And all I want to do is just simply increase my x's by 1. So I'm going to go with A2, which is where I put my negative 8, plus 1. I'll hit enter. Now as I bring my mouse back up to A3, I'm going to go to this box here in the bottom right corner, and I'm just going to pull down. Notice how I got the dotted lines coming, and when I let up, it now filled in all my values. So I now have a nice value from negative 8 all the way to 7. Well, here in column B, I want to do 2x plus 1. So again, I'm going to put it in the formula. So I'm going to type in equals 2 times, which is asterisk 8. What do I want to multiply by? Well, I want to multiply by the x value that's found in A2, and then add 1. Again, I'm going to go back to this B2. I'm going to highlight and pull down And now my Sheets has made me a table with all these values. Same thing for C. I'm going to go equals. In this case, I'm going to use parentheses, so I'll make sure and do my 1/2 times. Again, it's what's in A2 minus 2. And again, I can pull down. And thus I fill in all my values. Now, where is our solution at? Well, our solution is the column where the y values are the same. So in B and C, we'll look for what's the same. -15, -6, not quite. As you can see right here as I highlight, well, let me unhighlight because that's a little bit too big. Let me try circling. Notice here in this column right here, our y values are the same. So when x is -2, we got -3 for both equations. So thus our answer becomes -2, -3, because that's where the y columns are the same. Let me write that down. And that's how we can use tables in Google Sheets. Another thing we want to do is we want to be able to classify systems of equations. We classify systems of linear equations by the number of solutions that they have. Take a look at this image. Now notice in the first one, a system is consistent and independent if its intersecting lines that have exactly one solution. A solution is consistent and dependent if it has infinitely many solutions, which means the lines that coincide will be the same. And it's an inconsistent system if they're parallel lines which have no solution. In a consistent and independent system, you'll know it's consistent and independent because your slopes will be different. A consistent and dependent system, the slopes and the intercepts will be the same because they're going to be the same lines. And in an inconsistent system, the slopes will be equal, but your intercepts will not. Take a look at an example here on our last slide. Without graphing, is each system independent, dependent, or inconsistent? First system is -3x plus y equals 4. So the first thing that you want to do is you want to find the slope. So we have -3x plus y equals 4. And again, remember our slope is always going to be mothers are against boyfriends. That means that the opposite of A is +3 and B is 1. So we look at our second equation. I'll change colors here. Mothers are against boyfriends. So it's -1 over -1/3. So of course that's -1, and I'll multiply by its reciprocal, 3. So notice that the slopes are the same. So now we're going to have to go to the second step, and we're going to have to find the two intercepts. So we'll switch back here to blue. For -3x plus y equals 4, if I let x equal 0, that means y equals 4. And again, the easy way I found that is I just simply take 4 divided by the coefficient. The constant value divided by the coefficient of y. Same thing for the second equation. We'll take the coefficient and we'll divide it by the coefficient of y. So 1 divided by -1/3. Again, so that's 1 over, fix this here, need a little bit more space. So that's 1 divided by -1/3. That would be 1 times its reciprocal, -3. Thus 0, -3. That means we have a system where the slopes are identical, but the intercepts are not. That means that this system is inconsistent. Equal slopes, unequal intercepts, inconsistent system. These lines would be parallel. Take a look at our second example. 2x plus 3y equals 1, and 4x plus y equals negative 3. So again, let's find the slopes. For 2x plus 3y equals negative 1, mothers are against boyfriends. So that's negative 2 over 3. We'll change colors here. For our second equation, again, it's mothers are against boyfriends. That's negative 4 over 1. That's negative 4. So we need to go no farther. Slopes are unequal. That means it's an independent system. Don't have to worry about intercepts. I have unequal slopes. That means these two lines will intersect at some place, and it's an independent system. Finally, let's take a look at our last example. Y equals 2x minus 3, and 6x minus 3y equals 9. So again, we'll start with the slopes. It's in slope-intercept form, so m equals 2 over 1. Change up a little color here. This is in standard form, so we have to go mothers are against boyfriends. That's negative 6 over negative 3. Thus, that's positive 2. So notice that I have equal slopes. That means we have to compare the intercepts. And in this case, in our first equation, it's mx plus b, so that means the y-intercept is negative 3. In our second equation, we're going to find the y-intercept. We're going to take the constant divided by the coefficient of y. That's 0, negative 3. So notice that we have a system where the slopes are the same and the intercepts are the same. That means this is a dependent system. Because we have equal slopes, we have equal intercepts. That is how we work with systems of equations. Your assignment for today will be on mathexcelforschool.com.